Okay, so we're going to be comparing apples to oranges. And the very first thing we're going to do is determine the slope. So hopefully you remember how to do that. If I look at this, this goes up by 10. This goes up by 20. This goes up by 30. If I look over here, this went up by 1, went up by 2, went up by 3. So if I was to find the rate of change or the slope for this, I have 10 over 1, which is 10, because we have to make sure it's linear, don't we? Excuse me. Sorry about that. Look at that. So our slope for this one is 10, or our rate of change is 10. So if I look at this next one, I'm actually going to write it, I'll write it off to the side. So I have negative 12x plus 2y plus 30 equals 0. Now, in order to find out the slope, remember it has to be in y equals mx plus b form. So that means that we have to get the y by itself. So it'd be much easier to move the y instead of moving everything else. So I'm going to subtract 2y from both sides. When I do that, that cancels out. Now some of you have a really hard time at looking at it this way. You like the y on the left-hand side. Well, it has an equal sign, so that means I can actually write it this way. Okay, all I did was switch them around. That's perfectly fine. So I still have to get y by itself, so I need to divide everything by negative 2. When I do that, I get 6x minus 15. So my slope on this one is 6. Then last but certainly not least, we have determined the hourly rate of change, described in the situation given. Jane is a tutor and is paid $20 for a half-hour lesson. Okay, so she's paid $20 for every half hour. So remember, rate of change means how much per one. So we need to do, we can't divide by fractions, we have to multiply by the reciprocal. So if I multiply by the reciprocal, I have $40 per hour. Okay, so that was pretty simple. So now what we're going to be doing is we're going to be comparing apples to apples, meaning both of these, the first number one, they're both tables. They're both graphs. Then they're both equations. Okay, so we're going to be, it's asking us to, I can't even speak today, examine each set of functions and determine which has the greater rate of change. So which one has the higher slope? So if I look at this one, I get, let's see, that goes up by 3, this goes up by 3, this goes up by 4, this goes up by 4. So my slope on this one is 3/4. Okay. Then over, oops, I'm going to use a different color. So this one. Now, hopefully you realize this is going up, even though we're dealing with negatives. So let's see. I'm going to say that goes up by 8. And this one goes up by 8. This one goes up by 6. This one goes up by 6. So the slope on this is 8 over 6, which is 4/3. So we're looking at these two. Which one has a higher slope? Okay, 3/4 or 4/3. So 4/3, this one right here has the higher slope because 4/3 is bigger than 3/4. Okay, so let's use a different color. So I look at this. Now, 1, 2, 3, went up 3, it went over 6. So my slope here is 3 over 6. Now, boys and girls, this is a negative slope. So negative 1/2. We're going in the negative direction. I have no idea why that is there. So just ignore that. Okay, so we're going here. Oops. And then we're going across. So the height on that, it goes up to 7. And over here, it's going to, oh, doesn't that look like 3.5? So 3.5. So we have 7 over 3.5. If you put that into your calculator, I'm hoping that you see that that is -2. Now, both of these are negative numbers, but it's asking which one has the bigger rate of change. So we're not actually looking at the negative part of it. We're looking just at the 1/2 and the 2. Which one has a bigger slope? Which one has a steeper slope? So actually B has the steeper slope. Okay, the 2 is a bigger change than 1/2. Okay, so let's look at this one. I have to solve and get y by itself. So I get 6y equals -5x. Oh, I didn't change colors over there. I just realized that. Divide, divide, divide. I get y equals -5/6 x plus 10. Okay, and so over here, oh, it's already in that form for us. So, oh, on this one, we forgot to say what the actual, okay. So again, we're not looking at the negative sign on this, okay? That's not what we're looking at. Which one has the greater rate of change? Is 5/6 a bigger change, or is 1/4? So 1/4 comes out to, why can't I speak? I don't know, whatever, what I was gonna say. This right here is the larger change. Then last but not least, an ice cream shop is choosing a milk delivery service. The Spotted Cow charges $2.80 per gallon plus a delivery fee. But aren't we just looking at the rate of change? So the rate of change for that first one is $2.80 per gallon. The second one is Dairy Farms, and theirs is $2.10 per gallon. Why aren't we looking at the delivery fee? Because the delivery fee doesn't have anything to do with the slope. So we have a slope of 2.8 and a slope of 2.1. So which one has the greater one? So the first one does. So the Spotted Cow has the greater rate of change. Okay, so now we're going to be comparing linear functions. So we've been doing apples to apples where they were exactly the same. What we're going to do now is we're going to compare on number one function A and B, but one of them is an equation and then the other one is the graph. So let's look at this. The first one, this one's easy. Sorry about that. It's already in the form y equals mx plus b. So it was really easy to figure out what the slope is there. Then over here, we need to figure out what the slope is. So I'm going to go from here, and this goes through a lattice point. So I'm going to do that. So the slope here, 1, 1. But we're going negative. So this is a -1. Okay. So it's asking, make sure you read what it says. Identify which has a greater rate of change. Okay, so which one's a greater rate of change? Function A has a greater rate of change because slope for function A, slope is 8. Function B, slope is 1. Okay, so here we go for this next one. We have to do the same thing. We just have to compare slopes. So this goes up by 3, up by 6, and up by 9. Over here, this went up by 1, by 2, by 3. So my slope, let's see, 3 over 1, 6 over 2, that goes to 3 over 1, and a slope here of 9 over 3, which is still 3 over 1, so our slope here is 3. And then we look over here, and I picked 2 good points here and here. So this goes here, and then this goes here. So it goes up by 1. So my slope here is -1/2. So which one has the greater rate of change? This one right here. So come over here. We need y by itself, so I have to subtract the 6x from both sides. When I do that, I get -6x plus 1. So my slope here, the number that sits in front of x, which is the coefficient of -6. Okay, over here, I go up by 12, I go up by 12, I go up by 12. I go up by 2, I go up by 2, up by 2. Oh, so my slope here is 12 over 2, which is 6. Now, you may be saying, oh, the function f, but both lines have the same steepness, boys and girls. So this one is actually going to be neither, because both have the same steepness. Okay? Oops, sorry about that. They both have the same steepness. They're going in different directions, but their steepness is the same. Okay, so here we go. Alicia, Sherry, and John have been studying the rate of change, and we're discussing the best way to determine which linear function has a greater rate of change. So we're going to look down here at each one of these scenarios. So they're both looking at function g and function h, but they have different ways of doing this. So Alicia says, I can identify 2 points from the graph and from the table and use the formula. Let's look at the formula. It looks right to me. So on the first one, she used 0, 1. Okay, so she used that point right there, and she used 2, 2. Okay, so she plugged that in, 2 minus 1, 2 minus 0, got 1/2. That looks pretty good. So then she comes over to h, and she used the first one, and she used the second one. So 3 minus 1 and 1 minus 0, and she got 3 minus 1 and 1 minus 0. She says function h has the rate of change of 2, which is greater than g's. Okay, so that one sounds pretty good. Okay, can we do the slope formula for that? Yes, that's perfectly fine. So let's go over to here to Sherry. She plotted function h on the graph with function g. Okay, so she plotted, it looks like she forgot to actually connect the dots. That's okay. I notice the functions have the same y-intercept, but the function h has is steeper. Now, if you notice, Okay, so that's what it would have looked like. So this was function G and this is function H, and H has the steeper one. Okay, then we're going to look over at John. He says, I can see from the graph of the vertical or the G that the vertical distance increases by 1 unit for every 2 units. So all he did was he looked at the graph and he went like this. It went up by 1, it went over by 2. That's where he went there. Then in the table, as the x increases by 1, so he came like what we did earlier with the, he went here and he said this is 2, this is 1. So he came up with that slope is 2 and came up with H has the greater change. Now, how was Sherry's method different from John's and Alicia's? Okay, so Sherry graphed. Okay, Sherry graphed. Then, what's the difference between... Now, all three methods are perfectly fine. It doesn't matter. Okay? You know what I'm going to do? I'm going to actually write a sentence like I'm supposed to. Okay, so Sherry graphed where Alicia used the formula and John used visual deduction. Okay, and I just compared. Which one's the most efficient for this situation? I actually think John's is the best one, but does it matter? No. Okay, I like John's because I really didn't have to find the equation. I didn't have to use the slope. I could just visually look at it and figure it out. Now, it depends on who you are as to which way you like to do it. Okay. Okay, John and Alicia then encountered the two linear functions. So the fact that it says linear, we already know that it makes a line, so we don't have to go through every single one to figure out on the table what the slope is, okay? They want to determine which function had the greater rate of change. Alicia said that it wasn't necessary to use the formula to calculate for function I and to rearrange function G to the slope-intercept. Okay? John said that would take too much time. He said he only needs to rewrite J in the slope-intercept form. Okay? Well, they could both be right, but I'm going to actually go for John myself because look at this. 4x equals y because I added y to both sides. My slope is equal to 4 on that one. If I look over here, aren't all of the y values exactly the same? And didn't we say that anytime all the y's are the same, the slope is just 0? So, I would have gone with John. Okay, and we're going to skip 5.2. We're going to go over to 5.3. So as I look at 5.3, again, consider each representation, but this time it's 4 distinct linear functions. It's not just 2. We're going to do all 4. And then we're going to order the functions from least to greatest in the change. Okay, so that's important, least to greatest. So, I look at this. I'm going to come down. Oopsie daisy. I like how I figured that out. Okay, so that's 4. This is 4. It's going in the negative direction. So that's negative 4 over 4. So the slope here is negative 1. Then I'm going to go over here to this one. I need y by itself. So I subtract x from both sides, and I get 4y equals negative x plus 12. And then I divide by 4, divide by 4, divide by 4. I get y equals negative 1/4 x plus 3. So my slope on this one is negative 1/4. Okay. Then I come down to here. Now I already know it's linear. Okay, it's already linear, so I don't need to figure out the slope on every single one. So because sometimes you guys have problems with negative numbers, I'm actually going to use the two middle ones. This goes up by 3, this goes up by 2. So my slope on this is 3 over 2. Then over here, the used bookstore will pay 50 cents for each box of hardcover. 4 is the same thing as per. So that means the slope on this is 0.5. So we're going to look at this. Which one is the least? Which one is the greatest? Okay. Now, remember that when you're doing this, we're not talking about the negative and positive signs. We're looking at the the absolute value of it. Okay. So we're looking at the positive. So that would be 1. This would be 1/4, 3 over 2, and 0.5. So what is the smallest number of that? Hopefully you know 1/4 is the smallest. And then, by the way, this is the same thing as 1.5. So then 0.5 would be next, then 1, then 3 over 2. So that's going to give me B, D, A, and C. Again, when we're talking about the greater rate of change, we're not looking at the negative on that. We're just looking at the positive on it. Okay, so here we go. We're going to go to the next one. Again, it says each linear function. So we already know that it's a line. Shown describes the steepness of the initial climb of a roller coaster track. For each representation, let y is the height. Okay, so y is the height in feet. And let the x represent the horizontal distance in feet. Okay. Okay, so again, we're doing according to steepness. So right here on this first one, we have a slope of, goes up 5, it goes over 1, so my slope here is 5. So that means it goes 5 feet up for every foot across. So then I am going to add 9x, add 9x. I get 2y equals 9x plus 4. Divide by 2, divide by 2, divide by 2. I get y equals 9 over 2, x plus 2. So my slope here, is 9 over 2. Then I come down here. We already know it's linear. Oh, these have lots of halves involved. So which halves one I'm going to go with these because they both have halves. Makes it easier. So that's going to be, is that 11? And this is 2. Okay, so this is 11 over, oh, that was a horrible 11. And then last but certainly not least, it rises 3, so it goes up 3, and it goes over 1, so that means 3. Now, in order to do this, it is so much easier if you actually have it in decimal form. So 2 goes into 9 4 times with a half. 2 goes into 11 5 times and a half. So if I look at this, we're going smallest to greatest? Yes. So the smallest slope is 3, then 4.5, then 5, then 5.5. So the 3 is the smallest one, so Thunderbolt. Then 4.5 is Racer. Then 5 is Jackrabbit. And last is Pippin. Okay. So then, okay, we're almost finished. The linear functions shown. Describe the bank account for 4 students. Represent dollar amount. Okay, it says if each student continues to save money at the constant rate shown, who will be the first to save $500? Okay, so first things first, we have to find the constant rate of change. So that's the first important thing. That was horrible. That's okay. So this one went up from 20 to 40, so that's 20. It goes over 1, so our value is 20 here. Then I add here and I get y equals 12x plus 100. So my slope here is 12. Then I'm going to go here, so that's 15, and this is 1, so 15. Okay, let's see. Michelle opened her bank account on September 1st with $25, continues to deposit, so our slope here is 25. Now, it's great that we found the slope, but we actually need to find out when they're going to get to $500. So in order to do that, I have to actually find the B value. So if I went down 20 and went over 1, wouldn't I be at 0, 0? So that means my equation is 20x. So if I was to plug in 500 here, to find out how much money they'll have, I divide here, and it would take 25 months to get to $500. Okay, so then I plug in 500 here. So 500 equals 12x plus 100. Subtract 100, I would get 400 equals 12x, divide by 12, and no, I don't know that off the top of my head, so 400 divided by 12 would be 33 1/3 months. Okay, so down here, my equation down here, well, my slope is 15, my y-intercept is 60, so 500 equals 15x plus 60. So I subtract 60 from both sides. I get 440 is equal to 15x. Divide by 15. 440 divided by 15 would get me 29 1/3 months to get to $500. And last but certainly not least, there's a rate of $25 plus an initial $25. So I need to plug in 500. Subtract 25 from both sides. I get 475 is equal to 25x. I divide by 25. Divide by 25. 475. I know I should know this off the top of my head, but I don't. This would be 19 months. Okay, so which one would you go with that's going to get to $500 first? If you notice, it's the lowest number of months. So Michelle is the one it would take to get there the fastest. Okay.